Space telescope can do a lot more than just take incredible pictures of the sky. For the first time, the observatory is unequivocal evidence of carbon dioxide. In the atmosphere of a planet outside of our solar system 700 light-years away, on the gas giant WASP-39b, an important gas, was finally discovered. This discovery provides crucial information about the composition of the planet. In addition, the discovery was accepted for publication in the Nature magazine, which provides proof that Webb could one day identify and analyze carbon dioxide in the thinner atmospheres of smaller rocky planets. Before we delve into this astounding discovery, let's review WASP-39b's key characteristics. WASP-39b is a hot gas giant with a diameter approximately 1.3 times that of Jupiter and a mass roughly 1/4 that of Jupiter. Its high temperature of over 900 degrees Celsius or 1,600 degrees Fahrenheit contributes to its extreme puffiness. In February 2011, the WASP project identified WASP-39b, also known as Boca Prince, as a Jupiter extra-sounder planet. It is notable for having a substantial amount of water in its atmosphere. Additionally, the atmosphere of exoplanet WASP-39b was found to contain carbon dioxide for the first time ever. WASP-39b is located in the Virgo constellation and is approximately 700 light-years from Earth. The planet was given the name Boca Prince in honor of the beach Boca Prince and the Aracoke National Park of Aruba as part of the Name EXO Worlds campaign during the 100th anniversary of the contrary to the cooler, more compact gas giants in our solar system, WASP-39b circles is installed very closely at approximately 1/8 the distance between the Sun and Mercury, and it completes one circuit in about 4 Earth days. This planet was discovered in 2011 as a result of a small periodic dimming of the star's brightness when it transmits or passes in front of two stars. Other observatories, including NASA's Hubble and Spitzer satellite telescopes, had observed that the atmosphere of the planet contained water vapor, sodium, and potassium. NASA has just made public some spectroscopic data that just acquired from the gas giant WASP-39b on WASP-39b, which was previously believed to be devoid of haze clouds and water. The observatory discovered haze clouds and the undeniable presence of water webs. Unparalleled infrared sensitivity has confirmed the recent discovery of carbon dioxide on this planet. What then makes this conclusion plausible? This is because the starlight has been filtered to better comprehend exoplanets, all planets that orbit other stars. Scientists aim their telescope focus at the planetary atmosphere to determine its chemical composition. They accomplish this by analyzing how the atmosphere filters starlights at specific wavelengths that correspond to different molecules. Instead of observing them from above, researchers may use transiting planets like WASP-39b, whose orbit we observe edge on, to study the atmospheres of planets during transit. A portion of the starlight are partially blocked by the planet, resulting in overall darkness, while the remaining are transmitted through the atmosphere. Scientists can precisely determine the composition of an atmosphere by analyzing minute fluctuations in the brightness of the transmitted light across a range of wavelengths. This is true because gases absorb specific color combinations in varying ways. WASP-39b is an ideal subject for transmission spectroscopy due mainly to its inflated atmosphere and frequent transit. Initial conclusive proof of carbon dioxide. On July 10, the research team observed WASP-39b using WIP's near-infrared spectrograph and the small hill between 4.1 and 4.6 microns, and the resultant spectrum of the exoplanet's atmosphere provides the first concrete evidence of carbon dioxide ever discovered in an extrasolar planet's atmosphere. It cannot be disputed. There is no room for doubt it exists on the planet WASP-39b, according to Peter Galp, a planetary scientist and co-author from Carnegie Institute of Science in Washington, D.C. Carbon dioxide have been detected in previous observations, but never with such certainty. On the 24th of August, the announcement of the new telescope's first comprehensive scientific discovery was made public. In addition, it raises the possibility that similar greenhouse gases to those on Earth may exist in the atmospheres of smaller rocky planets. Zephyr Rustam, Colif and alumnus of Johns Hopkins University, was a member of the Just Transiting Exoplanet Community early release science team. He stated that as soon as the data appeared on his screen, the massive carbon dioxide feature caught his attention. According to him, it was a momentous occasion because exoplanet science reached a significant milestone. Every scientist is ecstatic about this discovery. An observatory has never before observed such a novel change. This reveals a wide range of colors in the exoplanet transmission spectrum ranging in length from 3 to 5.5 microns. Access to this region of the electromagnetic spectrum is essential for estimating the amounts of water, methane and carbon dioxide that is believed to exist on a variety of exoplanets. Natalie Battaglia of the University of California, Santa Cruz is leading the investigation. According to Battaglia, the discovery of a carbon dioxide signature on WASP-39 bits is encouraging for the search of atmospheres on planets with similar terrestrial sizes. Understanding a planet's atmosphere is crucial because it can shed light on the planet's evolutionary formation. The asteroid bombardment of the globe may have increased the carbon content of the planet and enriched the atmosphere with carbon dioxide. If the star's radiation removed any of the atmosphere's lighter constituents, the planet's atmosphere may contain more carbon dioxide. A different member of the research team, Miglania of Arizona State University, stated that carbon dioxide molecules are sensitive traces of a planet's birth. We can determine the proportion of solid to gaseous components used in the formation of this gas giant planet by paying close attention to the carbon dioxide component. In the next decade, JUST will conduct this measurement on a variety of planets, shedding light on the specifics of planet formation and the peculiarities of our own solar system. Carbon dioxide may exist in atmospheres throughout the universe, hiding in plain sight, even though it requires a powerful telescope like JUST to locate it. Carbon dioxide is one of the few substances present in the atmospheres of every planet in the solar system. According to Battaglia, it is a necessary chemical. Astronomers hope to use JUST in the future to detect carbon dioxide in the atmospheres of small rocky planets and stars like TRAPPIST-1 that produce carbon dioxide. Due to the fact that some of these planets are just far enough from their star to support liquid water, they would be excellent places to look for light. WASP-39 bits demonstrates, according to co-author David Singh of the University of Exeter, that exoplanets can have significantly different chemical compositions than planets in our solar system. We can only hope that the variety of exoplanets will aid in our comprehension of the numerous processes involved in planet formation and evolution. Water is primarily responsible for the strongest spectral features. Researchers were surprised by the quantity of water they discovered on this hot Saturn. Despite having anticipated its presence, WASP-39 bits may have evolved differently than its famously ringed neighbor because it contains so much more water. The presence of so much water shows that the planet really formed far from the start, when it was subjected to intense ice material bombardment. WASP-39 bits likely had a fascinating evolutionary history as it migrated in, traversing its planetary system on an epic journey and possibly destroying planetary objects at its core. WASP-39 bits is proving to be one of the most significant WASP discoveries made with the Hubble Space Telescope Spitzer Space Telescope and significant ground-based observations, such as the BUT observations as a Saturn mass planet with a bloated radius. Its low surface gravity makes it the ideal candidate for atmospheric characterization. In addition, the sky is exceptionally clear and exhibits spectral characteristics. A team at Exeter University led by Hannah Wakeford has now combined numerous data sets to create the planet's most comprehensive spectrum to date. The majority of the spectral characteristics are caused by water vapor, but there are also smaller lines caused by sodium and potassium K and a Rayleigh scattering slope at the blue end. This NIRSPEC prism observation of WASP-39 bits is only a portion of a much larger investigation. This also includes observations of 2 additional transiting planets made using various web-based equipment as part of Planet Studies. The investigation, which is a component of the early release of the Web Data Science Initiative, was designed to expedite the dissemination of web data to the exoplanet research community. According to Oxford University co-investigator Vivian Parminta, the objective is to rapidly analyze the early release science observations and develop open-source tools for use by the scientific community. This enables contributions from all over the world and ensures that the coming decades of observations will yield the highest. According to Natasha Patella, NASA emphasizes prompt research publication for a collaborative scientific process. Webb's abilities open up new possibilities for observing distant planetary atmospheres, promising more discoveries. The James Webb Telescope may help answer fundamental questions about and its isolation.